Hello kids, welcome to ICSE Chemistry Hub. All those who are new to my channel, kindly do like, share and subscribe it. Here you will be having in-depth knowledge about the ongoing chapter which is electrolysis. Today we will be doing part 6 of electrolysis. Those who have to go back to the previous videos can kindly check the description box where you will get all the links, or you can have a look at the playlist that is there on my channel. So all your doubts regarding electrolysis will be cleared with all these videos that have been put here. Today we are going to start with one of the most important and one of the last topics of electrolysis. This will be the last video for electrolysis. So let's dive into the topic. So we are going ahead with the next use of electrolysis. If you have checked my previous video, we had done the applications of electrolysis, clear? And one of the application of electrolysis was done in my previous video. What was the first use of electrolysis? It is used in something called as electroplating. Now what is electroplating? I am trying to electrolytically or with the help of electricity, I am trying to electroplate a metal. Now, what is the meaning of the word electroplating? I am trying to deposit, I am trying to coat a superior metal onto an inferior metal. Clear? Or we call it as the base metal. Today, we are going to start with the next use of electrolysis, that is electrorefining. Clear? This word comes from it's taken from two words. Electro means I can say electrolytically or with the help of electricity. Clear? And refining means I am trying to make it pure. I am trying to purify my metal. Clear? So whenever I want my metal in the purest form, I'll be using this method which is called as electrorefining. Let us go into the definition. Electrorefining, as I told you, is a process by which any impure metal is purified, clear, to give me a pure metal. But how is the process done? The process is done electrolytically, clear? Now this is the key word here, children. If the definition is asked in your ICSE grade 10 board examination, please do not miss out on this word. This is where you will be getting marks, clear? This is a word you have to write. So what is electrorefining, children? Once again, we'll go ahead with the definition. It is a process by which I am trying to purify a metal. But how is the purification done? The purification is done electrolytically. I am trying to make it pure electrolytically. Okay. So we will start with, in your portions, you only have the electrorefining of copper. Now the question is, why do I need to do electrorefining? Now, whenever we get a metal, can you tell me from where do we usually get metals, children? Yes, we get metal usually from the Earth's crust. It is taken out from the Earth's crust by a process called as metallurgy. What is metallurgy? Metallurgy is nothing but when I am extracting the metal, extraction of the metal from its ore. When I'm taking out the metal from the Earth's crust, it's nothing but metallurgy. But what is the problem that I usually face in metallurgy? My metal will be impure. Clear? I will never get it in pure state. So whenever I get an impure metal from electrolysis, I will be carrying out the process of purifying the metal. I will be refining the metal, whichever metal it is. Clear? And how will I be doing it? I'll be doing it electrolytically. For example, here in your portions, you only have the electrorefining of copper metal. Now, copper metal, I will get it out from metallurgy. But as I told you now, what is the problem with this metallurgy? My metal will be impure. Now, this metal, that is copper, now imagine I want to make a copper wire out of it. Now where will this copper wire be used? It is used in conduction of electricity. Can I use an impure block of copper? I can never use an impure block of copper. I need to purify the metal. So for that, I will be making use of the process which is called as electrorefining. What is electrorefining? Purification of the metal. Please remember, refining is purification. But how am I purifying the impure metal? I am doing it electrolytically. Okay. So here in your portions, we'll be starting now with electrorefining of copper. The same thing that you have done in electroplating, most of the principles here are the same. Okay. Now you know this electrolytic setup. You will be able to tell me that this is how a voltmeter looks like. We will be using what type of a current, children? We will be always using a DC current. Now what is DC current? Direct current is nothing but the current that you get from a battery. You have two metallic plates, as you can see in the diagram here. One is attached. It is attached to the negative terminal of the battery. The one that is attached to the negative terminal of the battery will be called as the cathode. And the one that is attached to the positive plate, the metallic plate which is attached to the positive terminal of the battery, will be called as my anode. So there is no confusion here. The metallic plate which is attached to the cathode, to the negative, is called as the cathode. The one that is attached to the positive terminal is called as the anode. Now this usually comes as a diagram based question for your board exam. And mostly the question that they ask is this: state what is used as a cathode and what is used as an anode. So children think it is electrorefining of copper. They will understand it. This is a setup used for electrorefining, nothing special about the cathode and anode. So they write cathode is nothing but copper, metal. Anode is nothing but again copper, metal. Now please pay attention here. ICSE board does not accept this as an answer. You cannot write for electrorefining cathode and anode are made up of copper metal. You have to use two other words here. You have to attach two other words in this copper metal. Okay. We will first come to the cathode. Always remember this. My metal will always be deposited at the cathode. Metal cannot go and deposit at anywhere else. So metal is always deposited at the cathode. So deposition of metal always happens at the cathode. Clear? So, and I am doing electrorefining. What is electrorefining? I am trying to purify the metal. Okay? So my pure metal will always come and it will be depositing at the cathode. Clear? So for deposition, I am using a thin, pure strip of copper metal. So if in electrorefining, they ask you what is the cathode made up of, please attach these two words there. What are the two words, children? It is a pure as well as it is a thin strip of copper metal. Can you see there's a clear difference in size? Why am I taking here a thin strip? I know my pure copper metal is going to come and slowly start getting deposited at the cathode. So for allowing it to come and stick at the cathode, I am just putting a thin strip of copper metal. And how should that thin strip be? It should be extremely pure. Okay? Because this is where my remaining pure metal is going to come and stick onto the cathode. So for cathode, please remember, what are the two words that you should attach? Always remember, my metal will come and get deposited at the cathode. So it should be a pure, and what is the next word you should remember? It should be a thin strip of copper. Okay? Whereas when I come to the anode, you must have seen in the previous electrolysis also, it is the anode that will itself start reacting. Okay? If it is made up of an active electrode. So here I am taking, can you see the difference in size? I will always use my metal plate that I get after metallurgy. So it is an impure as well as it is a thick block of copper metal. Both are made up of copper, agreed. But at the cathode, what type of cathode you will be using? You will be using pure as well as thin copper strip. Whereas when you come to the anode, please remember it is the anode that will itself start reacting. Okay? And what is our aim in electrorefining? Our aim in electrorefining is that we need to make it pure. We need the impure block to be made pure. So impure, as well as it should be a thick block of copper that we are taking. So I hope this difference is clear to you. Moving on, let us just look through the constitution of the electrorefining for copper. What is the electrolyte we have used? We have taken copper sulphate, but have we taken it in solid state? We know electrolysis can never be carried out in the solid state. So what type of electrolyte have I used, children? I have used aqueous. Aqueous means I have added water inside it. So I have copper sulphate plus water. And also, if you are remembering the electrolysis of copper sulphate that we did, we also added a few drops of an acid. And which acid in particular did we add? We added a few drops of sulfuric acid. What is sulfuric acid? It is nothing but H2SO4. Now the question again remains the same. Why to use acidified copper sulphate? What difference will the acid make to the electrolyte? Just remember 3 words here. What will sulfuric acid do, children? It will increase the conductivity of the electrolyte. Or in other words, it will allow huge amount of electricity to pass through it. So just to make electricity pass through it, I have added the third substance. What is the third substance here? It is nothing but sulfuric acid. So my electrolyte is nothing but acidified and aqueous copper sulphate solution. What is my cathode made up of? Always remember, your pure metal will come and deposit at the cathode. So you should take a pure and a thin block of copper metal, as you can see in this diagram. I have taken pure as well as I have taken a thin strip of copper here. Whereas at the cathode, at the anode, I have taken an impure block of copper metal, and also it is extremely thick block of copper metal. Okay. So here we are starting with the reactions of electrorefining of copper. That means I am trying to purify my copper metal which is impure, which I have got from metallurgy. Okay. So shall we start with the reaction? Again, my cathode is a pure thin strip of copper. Anode is a very, very thick impure block of copper. Let's see how the reaction will go ahead. Okay. So we are starting with electrorefining of copper. If you want, children, you can just take your notebooks along with you and you can start writing the reactions along with me. Okay. So electrorefining of copper, we will start. What is the electrolyte we have taken? We have taken copper sulphate. How will this decompose, children? It will decompose to give me Cu2 plus it will give me an anion called as sulphate, that is SO4 2-. Did I just add copper sulphate? No. In my electrolytic mixture, I have one other substance added. What is the other substance that I added? I added water. How will water decompose? It will decompose. By now, we have become an expert in writing the decomposition reaction of water. It decomposes as H plus OH-. H plus, here one H, here one H, it makes it 2 and there is one oxygen. So the decomposition reaction is correct. Okay, the next thing that is we have added here is I have made it acidified. What's the meaning of the word acidified? I have added a few drops of an acid. So how will this decompose, children? How many atoms of hydrogen? I have 2 atoms of hydrogen. So I'll get 2H plus I will get SO4 2-. This is what we had said. My electrolytic mixture has copper sulphate plus water plus I had added a few drops of sulfuric acid. So right now in my electrolytic mixture, when I passed electric current through it, it has led to the formation of ions. Now let us see how the electrolytic reaction will proceed. As usual, once you write the general decomposition reaction, we will start at the reaction at the cathode. Cathode, please remember your pure metal. Whenever there is a metal deposition that has to happen, my metal will always come and get deposited at the cathode. So cathode is having what charge, children? Cathode is negatively charged. So of course opposites attract. So it is C. What does C mean? Cations will run and come towards the cathode. C to C. What is the meaning of the word C to C? Cations will run and come towards the cathode. What's the other short form you have to remember? What happens at the cathode, children? CGR. What is C? Cathode. At the cations will gain electron and there will be a reduction process that will be going on. Okay. So cathode is negatively charged. Opposite ions will run and come. Which are the two ions that can come here? You have something called as copper cation or copper ion, and you have H plus ion. Again, there is a competition that is taking place between copper as well as hydrogen. Which one will be discharged? What is the meaning of the word discharge? They should lose their charge. They should become neutral atom. Okay. So we know the lower the position in the electrochemical series, the more is the capability for them to get discharged. We call this as preferential discharge. So which one do you think is lower in my electrochemical series? I have hydrogen. Just below that, you will find copper. If you have any confusion here, you can just have a look at my previous videos where I have explained this in detail. So we know copper is placed below in the electrochemical series. Clear? So which one will get a preference for discharge? Which one will be selectively discharged? It will be my Cu2 plus cation. If it is a plus here, nothing much to think. Put a plus here also. It becomes 2 electron. Now when does an element get a positive sign, children? When it has lost electron. And I want to make it discharge. Discharge means I want to make it neutral. So if it has lost 2 electrons, can I give it 2 electrons? It gains G. It has lost 2 electrons, that is why it has a plus sign. If I give it 2 electrons, will it become neutral? Yes, it becomes Cu neutral atom, or we call it as a copper metal. I have already told you what is the color of copper metal. My copper metal is reddish brown or pink color metal. Okay. So this deposition will happen at the cathode. Just have a look here, children. Which is the cation that has run and come towards the cathode? It is Cu2 plus. If it is a plus here, plus 2 electron, yes or no? And it will become neutral copper metal. Okay. So there will be where will this metal deposition happen? Very, very slowly you will see in the electrolytic cell. At the cathode, you will see a brown, reddish brown deposition of copper metal happening. So what I had actually put as a thin piece of pure copper metal, slowly what will start happening at the cathode? My mass of the cathode will start increasing. Clear? My mass of the cathode or the size of the cathode will start increasing because neutral copper atom or copper metal will slowly come and it will start settling on this cathode. Am I clear till here, children? Okay, so I hope the reaction at the cathode is clear to you. Moving ahead, let's start with the reaction at the anode. Now, anode is having what charge? Yes, it is positively charged. Opposites attract. So, when I say opposites attract, which ions will run and come towards it? We have SO4 minus and we have OH minus. This is also SO4 minus, so it does not make a difference. But so, which one will get discharged? So, no caliber IO. Okay. Ideally, it should have been hydroxide. But does that get discharged? No. None of the anions get discharged. Why? We know CNS. What is CNS? Copper. N stands for nickel. S stands for silver. What kind of electrodes are these? We call them as the active electrodes. Okay. So what starts happening here, children? If there is copper, nickel and silver, the electrodes, they themselves will start participating in the reaction. They are not interested in making any anion discharge. They themselves will start reacting. Now, as you can see here, what is it that we have taken at the anode? We have taken copper, metal as the anode. Okay, or we can say we have taken an impure thick block of copper. Okay, now copper, whether it is pure or impure, it is an active electrode. It will start taking part in the reaction. And how will we write the reaction, children? In bracket, even for your exam, you can write this ALO. Okay, anions at the anode. What is going to happen, children? At the anode, it is going to lose electron. So copper metal is going to lose. How will we denote a lose electron? We denote it with a minus sign. How many electron does it lose? -2. So anode loses electron. So if whenever it is losing electron, which ions will be formed? We know it will be Cu2+. Here it has lost 2 electron. We know whenever a metal loses an electron, it always gets a plus sign. So which ions are formed in the anode, children? Cu2+ ions will be formed. I hope till here it is clear to you. So once again, my anode is nothing but impure copper metal, and we know copper is an active electrode. So what happens at the anode? Cu, it will lose electron. Lose means minus. Whenever any metal, that is the reason why metals are called as donors. Whenever they donate electron, they are getting an electropositive charge. How many electron did it donate? Cu2+. So what has started happening, children? My anode has started slowly falling down into the solution as Cu2+ ions. Clear? Now this Cu2+ ions will be again taken up by the cathode, and it will make it as neutral copper atom, or it will make it as copper metal. Am I clear? So from the anode, my impure anode has started falling down into the solution, and it has started forming Cu2+. So can you see, it is a give. Something is falling down. Cu2+ is falling down. My copper metal at the anode is breaking down to form Cu2+ ions. This Cu2+ ions are again taken up by the cathode, and it is being converted into copper metal. Okay. Now in this is the same electrolysis that you have done for electroplating also. The reactions remain the same. Okay. But in this diagram, so just have a go through this slide, children. The impure block of copper gets used up. I have just now told you it has started breaking up. It has started dissolving into the solution. It has started giving Cu2+ ions. Okay. Now, if I don't know if you have a look at this reaction. Okay. Can you see here? There is something called as anode mud. Okay. This anode mud is nothing but these are impurities. Okay. These are the impurities. As I told you, what did we take in the anode, children? We took an impure block of metal. My copper metal, whatever was there, it had started breaking down to copper, Cu2+ ions, which is used by the cathode to make copper metal. But what about the impurities that are there in this copper metal? Okay, can you see? These impurities have started settling down. Okay, so the pure copper metal dissolves out, and it will form Cu2+ ions. Whatever copper is there, it has started at the anode, has started now becoming Cu2+ ions. It is then taken up by the cathode, and it will change into pure copper metal. It will start depositing at the cathode. Now please remember here, children, there are two types of impurities that can arise. There can be a soluble impurity, and there can be an insoluble impurity. Whenever I am taking an impure block of copper, there can be two types of impurities that can come. There can be a soluble impurity. Where will the soluble impurity go? The soluble impurity will get itself dissolved in the electrolyte. Okay? It will mix in the electrolyte. It will be there in the solution. What happens to the insoluble electrolyte, children? The insoluble electrolyte, it cannot dissolve in the electrolyte. Okay. So what starts happening, children? Because it is impure, because it is insoluble. Okay. All the insoluble impurities will start settling down at the bottom. We call them as anode mud or we call them as slime. Please remember these two words. So if they ask you in the exam, what is anode mud? The other name for anode mud is slime. Please remember, these are the impurities, but I just now told you what type of impurities are these. These are nothing but the insoluble impurities that was present in the anode when you took an impure block of copper will be called as the anode mud or the slime. Okay, children? So I'm once again just telling this. Please remember, copper, pure metal, pure thin metal is kept at the cathode and my impure metal will be placed at the anode. Okay, my anode has impurities. The pure copper metal will start breaking. My pure copper metal has started breaking. Whatever copper is there, that will break into Cu2+. It will be taken up by the cathode and it will convert it into copper metal. Okay. There are two types of impurities that can come in this metallic block. Okay. So this block of metal has two types of impurities. It can either be a soluble impurity or it can be an insoluble impurity. What will happen to the soluble impurity? My soluble impurities will dissolve in the electrolyte. We will not be able to collect it. Okay. So they dissolve and they vanish into the electrolyte. But whatever insoluble impurities are there, my insoluble impurities cannot go into the electrolyte. So slowly, because of the weight, where will they start settling down? They will start settling down at the bottom of the electrolytic cell, or where my anode is placed, just below that they will come settle down. We call them as the anode mud or we call it as the slime. Okay. So if they ask you in the exam what is anode mud, just say the insoluble impurities that are there in the electrolytic in the anode are called as anode mud. The other name for anode mud is slime. So this is all about the electrorefining of copper metal. Hope you have understood this video. Please do like, share and subscribe my channel, children. And if you have any positive feedback to give me, kindly do so in the comment box. I'll be going through each one of it. With this, we come to an end of this chapter. In my next video, we'll be discussing the specimen paper of 2026. So please stay tuned. Please do like, share and subscribe this channel. Thank you.